Rhombi and kites. Remember that rhombi or rhombuses, all of our sides are congruent. So finding the perimeter for a rhombus is as easy as just multiplying whatever your side is by 4 or just adding them all together. The perimeter of a kite, same idea. These two are always congruent. These two are always congruent. So to find the perimeter, add these two plus these two, and you get the perimeter there. So again, here I'm just recommending for perimeter, add all sides. No special formula needed here. But for area though, area is a little bit trickier. Our formula to find area of a rhombus or a kite is d1 times d2 divided by 2. Now the d's here represent the diagonals. So d1 would be this red diagonal, d2 would be this blue diagonal. Same thing in our kite here. This blue diagonal from vertex to vertex is our d2, our diagonal number 2. And this red line here is our d1, our first diagonal. And so to find the area, all we do is multiply those diagonals and divide by 2. So let's go through some examples here, one of each. So let's start with the example of a kite. Now again, a little bit tricky here because for perimeter, we're missing some of these sides. Now, because I know that this is 12 and these two are congruent, then I know that this one will also be 12 inches. But to find the other one though, I have nothing else to go on. But one property I remember from kites is that their diagonals are perpendicular. Now seeing this right here and highlighting these sides should make you aware that just like the trapezoid in the previous example, we have a right triangle, and we're going to use that right triangle to use Pythagorean theorem to find what this side is. So I have a squared plus b squared equals c squared. Now here my a, I'm going to let that be 3, my b is 4, my c is x. So I have 3 squared plus 4 squared equals x squared. 3 squared is 9, 4 squared is 16, and x squared is still x squared. 9 plus 16 is 25, so that's my x squared. And just like last time, remember I need to take the square root of both sides, which gives me x equals 5. So I know that this x here is 5, which means this is also 5. So now that I know all these sides, now I can find the perimeter, 12. And I'll do this vertically now, so I have space. To find the perimeter, I add all these, 12 plus 12 plus 5 plus 5. This is 24. This is 10. So 24 plus 10. Perimeter is 34, and my units here are inches. So 34 inches. Now area, again, a little bit tricky. Now I know that these two pieces are congruent. So this is 3 inches right here, which means this must be 3 inches, 2. So let's go ahead and label that, which means that my D1, 3 plus 3 is going to be 6. So let me write that down here before I forget. D1 is equal to 6 inches. But D2, on the other hand, I know this piece is 4, but I have no idea what this piece is. So again, it looks like I'm going to use Pythagorean theorem because I have another right triangle going this way. So I know that this is 3. My hypotenuse is 12. So I'm looking for B here. And I'm just going to put B. So let's use Pythagorean theorem. Let's go to do it over here on this side. So A squared plus B squared equals C squared. A is 3, so I have 3 squared. I don't know what B is. That's what I'm looking for. And C squared is 12 squared. So I know 3 squared is 9. B squared is still B squared. 12 squared is 144. Now here this time, since my B squared is on this side, I'm going to subtract 9 from both sides. so that I get the b squared by itself here, and 144 minus 9, 135. Now that's b squared, so I take the square root to get b. So the square root of 135, which if I plug into my calculator is 11.618, so 11.62. So now that I know what my b is here, 11.62, now I know what my d2 is. So d2 is equal to 15.62, because if I add 11.62 plus 4, then I get 15.6. So now I know d1, I know d2, so now I can find the area of my kite. So A equals d1 times d2 divided by 2. d1 times d2 divided by 2. And so if I plug this in my calculator, 6 times 15.62 divided by 2, 46.86. So my area here is 46.86. My units here are inches, so inches squared. So again, a little bit tricky because of this Pythagorean theorem stuff, but the area, simple as d1 times d2 divided by 2. So as long as you got d1 and d2, no problem here. Let's continue with a rhombus. So find the perimeter and the area of the rhombus if AB equals 7 meters, AC equals 6 meters, and BD equals 8 meters. So when I have a problem like this, always start by labeling the numbers that we have. So I know AB is 7, AC, this one here is 6, and that's my entire diagonal, 6 meters, sorry. And BD, my other diagonal, is 8 meters. Now in this case, I do have D1 and D2, but let's find the perimeter first. So since I know that this is 7, and I know in a rhombus, all sides are congruent, then all of these are 7. So to find the perimeter, it's easy as 7 times 4, which in this case is 28. And our units here in meters, so 28 meters is my perimeter. Now for area, again, my formula is D1 times D2 divided by 2. So I know what D1 is, I know what D2 is, so all I have to do is 6 times 8 divided by 2. 6 times 8 is 48. 48 divided by 2 is 24. So my area, 24. My units is meters, so for area it's meters squared. I'll put an A here. So area equals 24 meters squared. Let's continue. So on a regular polygon, remember that the perimeter for a regular polygon, knowing that all sides are congruent, then to find the perimeter, all I need to know is the side length times the number of sides. And for area, I have the opossum, let me do this in green, times the perimeter divided by 2. And remember that the opossum of a regular polygon is the line that goes from the center to the side and is perpendicular to that side. Or that our side length is over here on the edge. This right here is the radius of the polygon. And we don't use that radius for anything except calculating the opossum or the side length if we need to. But this radius is not used for the perimeter or for the area. The only thing we're using for perimeter and area, perimeter in this case is just the side length times the number of sides. Area, using the opossum times the perimeter. Or if you want to extend that formula out, you can also have opossum times the side length times the number of sides over 2. Both of these formulas will get you the exact same thing. So let's take a look at an example. Here I have a regular polygon. I know all these sides are congruent, all the angles are congruent, therefore this polygon is regular. And I have 1, 2, 3, 4, 5, 6, 7. So that makes this a heptagon. So let's write that stuff down. I know that n here is 7. And the side length that I'm given is down here 13.2. Remember, this is my opossum, so I'm using that for the area. But I don't need that for perimeter. So to find the perimeter, remember side length times the number of sides. So I have P equals 13.2 times 7. If I pull up my calculator and figure that out, 13.2 times 7 gives me 92.4. So 92.4, and there's no units here. So 92.4 units of perimeter. And since I already know the perimeter, then for area, so I'll use opossum times perimeter divided by 2. So my opossum here, I know that's 13.5. So I have 13.5 times, now do it in purpose, times my perimeter, which was 92.4. Then all that divided by 2. So I go in my calculator, 13.5 times 92.4 and divided by 2, 623.7. And again, unitless, so 623.7 units squared.